Hi everyone, I welcome you all for today's session. Today in this session, we shall discuss about the characteristics of semiconductor diode. That is the part of diode circuit. Right. The diode, as I named it as a semiconductor diode, there are few semiconducting materials which are used to develop the diode. And those semiconductor materials are germanium, which is denoted as Ge, silicon, which is denoted as Si, and gallium arsenide, which is denoted as GaAs. So these are the major semiconducting materials used to develop the diode. Now let us understand among these three which is better, right? So I will give some important specifications of a diode which has to be understood or which has to be considered while selecting the type of diode by which it is made up of material, right? Means, for example, if you consider a mobile, when you go for purchasing of any mobile in a shop, we will concentrate on few major concepts, few major points. That is like mobile camera. What is the megapixel of that particular mobile? Rear camera, front camera, right? And next point we'll consider the storage capacity, and also we'll consider the display size, right? Battery backup. These are some important points which we will follow. We need to go through. Same way, when you are selecting a diode, you need to make a decision. Means whether you want to select a germanium material to develop the diode, or you want silicon type of diode, or gallium arsenide type of a diode. You want to make a selection among these three. Means there are some specifications points which has to be considered. Now that has been mentioned on the board. You can look at here. Semiconductor, these are the materials: germanium, silicon, and gallium arsenide. Particulars are nothing but you can say specifications which we need to consider. That is, the major thing is the threshold voltage, reverse saturation current, and breakdown voltage. In my previous video, I have given a complete idea about what actually these parameters are. Right? Threshold voltage is nothing but that is the minimum voltage required to turn on the diode. Reverse saturation current is nothing but, name itself indicates, it's in a reverse bias condition. That is the current which will create some flow of current in a reverse direction, right? So this is the reverse saturation current. We should always try to have a very less reverse saturation current. Now this is the breakdown voltage. Even this is related to the reverse biased. In reverse biased, there is a limitation of a voltage. That maximum voltage, or in other words we can say peak inverse voltage. Maximum reverse voltage which can be applied to a diode without damaging it. So that will be the statement for a breakdown voltage. Now let's see what are those values. Okay, if I consider the germanium type of a diode, the threshold voltage means the minimum voltage required to turn on the diode in forward bias is, I hope you all have an idea about that, 0.3 volt. This is the voltage must and should it's required to start the diode. Before this, diode will not be in conducting mode, right? For reverse saturation current, if you consider the reverse saturation current, that is 1 microamperes. 1 microamperes. See this very small current over there in terms of micro, because it is in reverse direction. Next, we have breakdown voltage. The breakdown voltage for this germanium type of diode will be up to 400 volt. The range will be up to 400. It means in reverse direction, in reverse bias, I can give up to 400 voltage. If you exceed more than that, damage occurs. Diode will be damaged. That is the point. Now, same specifications if it is of silicon diode. Let's look into that. If it is silicon, the threshold voltage will be, I hope you all know this, 0.7 volt. That is the threshold voltage. Minimum voltage to turn on the diode. Reverse saturation current, that would be 10 picoamperes. It is in terms of pico, 10 picoamperes. And the breakdown voltage will be, this is important funda here, it is 50 volt to 20 kilovolt. The range of the breakdown voltage is 50 to 20 kilovolt. It's going to vary based on the surrounding temperature, right? So it can apply up to 20,000 volt. So that is the advantage of silicon type of diode. Now let's see, we'll compare. After looking into these parameters, let us make the comparisons of all these three type of diodes, and we'll come to a conclusion in this video that which type of diode is better. Okay. Now let's move for the third one, gallium arsenide. So here the threshold voltage for this type of diode is 1.2 volt. That is the threshold voltage. So you have to give minimum 1.2 volt to start this diode. Then reverse saturation current is 1 picoamperes. Breakdown voltage will be 50 volt to 20 kV, as similar as silicon diode. Right. So this is the information which we need to concentrate while selecting the diode. By looking into this information, we can also conclude that which is better. Once you look into the threshold voltage, if I look into the threshold voltage, always threshold voltage has to be very low, because that is going to be applied in forward bias. When if 0.3, 0.7, 1.2, if I compare this, 0.3 is the best option. So when I compare with the threshold voltage, this is going to be the best option, right? But I hope you all be knowing that we discuss almost all maximum type of diodes what we use. Semiconductor diodes are all of silicon type, not germanium type. In short, I can conclude, I can say that silicon diode is used widely. But here you may be confused. Sir, 0.3 volt is good, or it's the best option. Means this germanium voltage is starting earlier than the silicon voltage, right? Silicon diode, right? Germanium diode is starting earlier than the silicon diode. Then why this is used widely? Yeah, this may be the question you may be having. Let's come to that point now. Look into this, the breakdown voltage and even this current. I told you that the reverse saturation current should be small, right? This is 1 microamps, this is 10 picoamperes. So this is smaller than this, right? So here silicon diode is better in that option. And one more major point here is the breakdown voltage. Germanium can withstand only 400 voltage in the reverse bias, whereas silicon can withstand up to 20 kilovolt, right? So this is the major advantage of silicon diode. Even you can compare this with GaAs, that is gallium arsenide. There, this is same. Even reverse saturation current is also good. These are the two advantages we have. But this 1.2 volt is not acceptable. It's not acceptable. Means in forward bias we have to give more voltage to start the diode, right? So comparing, when all these comparisons, according to these comparisons, this is going to be a best option, silicon diode. Again, we have some other applications of germanium, silicon and gallium arsenide. We can't say that these two are not at all used. Yes, we are using this. Let's see. I will tell you now how these are applicable to different applications. And before going to the applications of these types of a diode, now let's understand the characteristics. The same picture what I have given in a table has to be represented graphically. That will give you the characteristic curves of a diodes. Now let's look into the characteristics of a diode. Now let us see how to plot it in a graphical way, the characteristics of a diodes. Here I have just represented those parameters which are useful to plot the graph. So let us start with this gallium arsenide. So in forward bias we have 1.2 volt, that is the threshold voltage required. So I have four regions here. This is the forward bias region, positive voltage and positive current. ID VD indicates diode current, whereas this is reverse saturation current and reverse voltage, right? So in forward bias, let us plot, let's see how it's going to be. I will take the blue marker. Okay, it is 1.2 volts. So here I have represented it. So up to 1.2, slowly the current will be increasing up to 1.2. Once it reaches that 1.2, the current starts increasing exponentially like that. That is the concept. But in reverse bias, in this reverse bias, at 1 picoampere, see here I have 5 pico, 10 pico and 1 micro, it is increasing in the reverse direction. And this is where somewhere we have the 1 picoamperes. So in reverse bias I can say the reverse saturation current is 1 picoamperes and it will be stable unless and until we apply the breakdown voltage. Once that breakdown voltage occurs, so I told you that the breakdown voltage is in the range of 50 to 20 kilovolt. It's a maximum breakdown voltage. So somewhere it will be carrying this 1 picoamperes, for a longer region up to the 20 kilovolt. After that, it's going to be breakdown occurs. So this is the way how we can plot the characteristics of a diode using this information. Okay, now let's apply it for the silicon diode. I think you can understand and you can represent it by your own. Okay, so silicon, the forward condition is 0.7 volt is the threshold voltage. So let's plot it like this. So 0.7, from there it will start conducting. So you can increase it exponentially. Whereas in reverse bias, same, it's going to be 10 picoamperes. Sorry, I have written it as 1 picoampere here. It is going to be a 10 picoamperes. So saturation current will be up to 10. So somewhere here. So you can get it like this. So 10 picoamperes and it will be flowing like this. Right. So it will reach up to, means I can plot it like this only, because both gallium arsenide and silicon have the same maximum breakdown voltage, but the currents are different. See, this is what the current we get if we use a gallium arsenide, but this is what the current we get in silicon diode in a reverse direction. Now let's see germanium. So its forward biasing is, threshold voltage is 0.3. So somewhere here itself it will get saturated, 0.3. So in this line we get the threshold voltage. There itself it will start conducting and giving a exponential current. In reverse bias, it has to have a saturation current of 1 microamperes. So the current will be flowing like this, 1 microamperes it will be flowing like this. And breakdown voltage is very less, it's up to 400. So somewhere we can get the plot like this. So somewhere this is 100. So somewhere we can just exceed it. Somewhere here we get a 400. So maximum it can withstand up to 400. So this is the problem with the germanium diode. This is the problem with the germanium diode. The saturation current is also more, reverse current is also more, and breakdown voltage is less. That's the reason this is not used widely. Gallium arsenide, the threshold voltage is very high. That's why even this is not used widely. Whereas silicon diode, it is having a moderate threshold voltage and also moderate reverse saturation current, but very good breakdown voltage. So that's the reason silicon is a famous semiconducting diode device. Now let's look into the applications of these three different types of semiconducting diodes. Here are some of the applications of different diodes, and also we can conclude by this table. Okay, germanium diode is going to have the important characteristics which we already discussed. I have framed it in a table now. It is having high reverse saturation current, very low breakdown voltage, but one thing is high temperature sensitivity. It is highly sensitive for the temperature variation. So that is the reason that characteristics made it to be used in a photodetectors and a security system. So where the temperature is increased, this diode will get affected, and that can be used for giving some alarm and all those things. So security system, there we can use it, or photodetectors can be used, made by the germanium diode. So based on the characteristics, we will go for an application. Because of high temperature sensitivity, these are the applications of this diode. Whereas silicon, it's having very good temperature characteristics, very low reverse saturation current, it is almost 1 picoamperes, excellent breakdown voltage and low cost. Because of this low cost and excellent breakdown voltage and also with a low reverse saturation current, it is widely used in the electronic field. All rectifiers, clippers, all whatever the electronic applications we have, there we use these kind of silicon diodes. VLSI circuits are also made up of the silicon semiconducting diodes. Now the last one is the gallium arsenide. These characteristics are also similar to the silicon diode, that is good temperature characteristics, very low resistance, reverse current, it's less than this. Okay, 10 picoamps this is for silicon, whereas 1 picoampere for gallium arsenide. So that is excellent breakdown voltage, but it's high speed operation. So because of high speed operation, it is high speed than this silicon. So because of high speed operation, it can be used for LEDs, solar cells, and also having better temperature. So some ways it can also be used for as a photo detecting diodes. So this is how the characteristics and the types of semiconducting diodes can be classified and characteristics can be understood. I hope this is useful for you guys. Just like if it is useful and share among your friends. Thank you.